Assalamu alaikum, dear students. Today we are going to discuss first and second chapter of fluid mechanics. Today's class is actually our revision class because a few students were asking about revision before exams, or they were looking about the topics which we have discussed basically in our previous lectures. So today I decided to conduct this session for you, not only to discuss the topics we have read in our previous lectures, but also related examples or other important results which we have derived, that they are essential for you. First of all, as all of you know, that we started from not from the first chapter, but before that we discussed a few basic concepts related to fluid mechanics. So I will start from there. And before starting that, uh, those basic concepts, first of all, I would like to introduce few applications of fluid mechanics. That what is the scope of fluid mechanics basically, where fluid mechanics, in true sense, is applicable in your practical life. So first of all, our topic is application of fluid mechanics, that where fluid mechanics basically applies, what is the scope of fluid mechanics, and where it's applied actually. Here we have a few applications of fluid mechanics, scope of fluid mechanics, where this particular field is applicable. First of all, knowledge and understanding of the basic principles and concepts of fluid mechanics are essentials in the analysis and the design of any system in which fluid is the working medium. First application, actually, all those systems in which fluid is used as a working medium, for all those systems or for the study of those systems, we have to know some knowledge about fluid mechanics. Secondly, the design of transportation requires an application of the principle of fluid mechanics. Design of transportation requires application and principle of fluid mechanics says that actually all those transportation designing system, it requires basic principles of fluid mechanics. Next, propulsion system of space flight as well as toy rockets is based on a principle of fluid mechanics. Actually, all those systems in which gases or liquids are basically using, in all those systems, knowledge of fluid mechanics will be very helpful for the better understanding. The design of all types of fluid machinery, including pumps, fans, compressors, and turbines, clearly requires knowledge of basic principle of fluid mechanics. In the similar way, pumps, we can say fans, compressors, turbines, all these machineries are basically related to the fluid, or in which medium basically the liquid or gases are basically used. They are basically material medium. So to study these all these things, we should have better knowledge of fluid mechanics. Similarly, lubrication is an important. They are lubrication, heating and ventilating systems for foam, offices, buildings. All these systems basically requires a very solid knowledge of fluid mechanics. Blood circulatory system is essentially a fluid system. The design of artificial heart-lung mechanics, breathing aids, and other such devices must rely on the basic principle of fluid mechanics. The application of fluid mechanics include a variety of machines ranging from water wheel to airplane. Okay, water wheel to airplane, we have a lot of machineries, a lot of systems, a lot of machines, we can say, in which fluid mechanics rules are using. Study of fluid provides an understanding of a number of everyday phenomena, such as an open window and door together creates a draft in motion. That was a very interesting phenomena. If we have open window and door at the same time, basically, then that draft produces, that is basically the due to the motion of air. So air, as you can say, that may be categorized under the category of fluid. So this also included in under discussion of fluid mechanics. Window tunnel represents a safe and judicious use of properties of fluid mechanics. Okay, till now I can say that we have here discussed different 11 applications or fields or the places where rules of fluid mechanics may be used easily, or fluid mechanics came into action for the study of fluid mechanics, or where fluid mechanics principles may come into play. So these 11 principles may be asked in your exam, just like a question, uh, what is the scope of fluid mechanics or the applications of fluid mechanics, how fluid mechanics principles are important, or why these rules are important. So in such types, we may ask few questions from you in your examination. Now we have basic concepts. They are very important, due to which I have from here we have basically a reviewing portion. We will try to revise each and every concept, but here I will not in depth, I will not describe you in depth each and everything, but I will try to just overlook definitions or phenomena or concepts that in this section we have actually discussed that particular concept, so that we can just summarize the complete chapter over here, because our focus is now we are focusing only to revise or to just check out our checklist, those things that which we have studied in our previous classes. First of all, we discussed few basic concepts, which were including matter, definition of matter, that what is matter, anything containing mass and weight, and further we studied that there are two broader categories, fluids and solids. Fluids are the categories in which we have liquids and gases, in which liquid is categorized as incompressible flows, which have definite volume but no definite shape. And then gases were the compressible flows, which have definite volume but no definite shape. After that, there was a concept of shear force. Shear force, actually, the force was acting, that was also discussed in next later chapters, that force was actually acting along two components, along the surface and normal to the surface. The component of a force that was acting actually tangentially or along the surface of any body, that was termed as shear force. And then we can also see tangential component of the force is the shear force. Mechanics, most renowned definition, the branch of science in which you study the behavior of force in a body either at rest or in motion is known as mechanics. You are dealing with the bodies either at rest in motion. After that, we categorize another category that was fluid mechanics. That what is fluid mechanics? In which you study the behavior of forces either at rest or in motion. If that was in rest, that was fluid statics, and if that was moving with particular velocity, then that was discussed in fluid dynamics. Fluid flow, moving flow was basically fluid flow. There were two types of flow: open flow and closed flow. Open flow was when the confining boundaries were relatively large distance or infinite distance, but between two confining boundaries, that was the flow. Set type of flow was a closed flow. And then control volume. Till last topic, which we discussed in chapter number 4, last article, there were also each and every geometrical diagram. We assumed few control volumes. So control volume was actually an imaginary surface which we assumed, and through which we can say that through which fluid can flow basically. It was an arbitrary region or space through which fluid flow. The boundary of the control volume is called control surface, and its boundary was basically control surface that was in a that may be possible in a rest or in motion. Incompressible flow in which density was negligible, density changes basically. Those flows in which density changes were negligible, they were incompressible flow, but in which there may be significant variations in density, they were termed as compressible flows. After the density, fluid property as mass per unit volume was basically density. Newton's law of viscosity, shear stress was directly proportional to the rate of deformation. Mu was constant of proportionality. That was termed as viscosity of the fluid element. Viscoelasticity, those fluids having both viscous and elastic effect, and that contains two properties: viscosity as well as elasticity. Viscosity, what was viscosity? That was measure of resistance of sliding motion of one fluid layer over another layer, that was termed by mu. And the nearer the fluid layers were, larger will the viscosity. And that was its mathematical relation, that shear stress was directly proportional to the rate of deformation, and mu was constant proportionality. And if you find out or we solve it for mu, that mu may be termed as tau ix over du over dy. After that, we have elasticity. Elasticity is a property of the fluid that comes back to its original position when a shear stress is applied on it. That when shear stress is applied on a particular body, then its capacity to change to its original shape or its original position. That was elasticity. Viscoelastic fluid. Viscoelastic fluid are the fluids that have both viscous and elastic characteristics when we deform them, in which both viscous and elastic factors are present. Honey was the best example that is viscous as well as elastic. Kinematic viscosity, ratio of absolute viscosity to density, ratio of mu over rho, that was kinematic viscosity. And further we discuss about Newtonian and non-Newtonian fluids, in which shear stress was directly proportional to the rate of deformation, that were Newtonian fluids, and in which shear stress was not directly proportional to the rate of deformation, they were termed as non-Newtonian fluids. And micropolar fluids, in which they were class of fluid having non-symmetrical stress tensor, in which stress tensor was not symmetrical. Viscous flow, the fluids with non-zero viscosity were viscous, and in which zero viscosity, actually zero viscosity, it doesn't exist. So I told you in the very first lecture that here we have only to assume the zero viscosity or just imagined viscosity, and steady flow, time independent, unsteady flow in which time fluid properties also depends upon time. Uniform flow, if every cross-sectional area contains same velocity or velocity as constant normal to the flow, that was uniform. And non-uniform, into every cross-sectional area velocity is not constant. Surface force, that was acting on the boundary through direct contact. Body force, surface force, the example was pressure, and body force, those forces were body force which were acting without direct contact, and electric forces, magnetic forces were the best example of those body forces. Laminar flow, flow in which lamines are layers or smooth layers. Actually, we will discuss all those laminar turbulent flows and internal and external flows within boundaries, confining boundaries, and internal flow basically inside the boundaries, and external flows in which body is immersed or unbounded. So that was external flow. Internal flow example, flow in pipes, and external flow over the body, just like a ball is moving through the air or liquid. Velocity profile, geometrically, if velocity is represented, it's represented velocity profile, and the developing flow in which velocity profile basically changes with increasing distance. That was a developing flow. Fully developed flow, after a few time later on, there will be no change, there will be no further change in velocity. Such type of flow, after that there will be no further change in velocity. That is known as fully developed flow. Entrance length, it's basically downstream length in which fluid fully developed to, in which fluid basically developing to fully developed flow. Fluid basically converted from or reached fully developed flow, that is entrance length. Boundary layer, near the solid boundary, a region in which strong viscous effects are present, that was boundary layer. And lastly, no slip condition, that whenever a fluid layer came in contact basically with any solid layer, then it will move with the same boundary, same velocity with which boundary is also moving. If boundaries are test, then the first layer which came into contact will also move with the same velocity. That was basically no slip condition. Okay, till now we have just finished all the definitions frequently or in a very speedy way, so that you have to know that all these definitions are included in your syllabus point of view, and all of definitions should be used to focus so that you may prepare your paper in a very good way. Okay, now we move towards chapter number 1 and revise all 4 chapters for you.